let's go. Number 14e. B times D. Well, here's B. You can tell it's a 3 by 1. D is a 2 by 3. Well, this only has one element in it. This has two elements in it. Can't do it. All right, A times B. Well, look guys, this has 3 elements in it. This B has 3 elements in it, so this is winner, winner. Now I'm not going to take time to rewrite it because it's set up for me. But this is going to be a little tough mathematically to memorize all this, but we'll see. So we got to throw this through all of this, and that's going to go right here, and then we got to throw this through this column, and that would go here, and then we'd be done. So let's do it. So 4 plus 18 is 22, plus 3 is 25. Then we go negative 8 plus 0 plus 15. Well, negative 8 plus 15 is 7. So there would be my answer. And now we got to find the inverse of C. Well, if we look at C, it's right here. If you remember our rule, the rule is it's 1 over the determinant of C times, if this is A and this is B and this is C and this is D, sorry for the mess, the rule is you switch D and A, you just take the opposite of B and the opposite of C, and then you follow this little format. So what's the determinant of matrix C? Well, that'd be 56 minus 27, which would be 28. So that's 28. Now we just follow these rules here. Switch A and D, so negative 8 is up here, negative 7 is there, and then this becomes its opposite, negative 9, and this becomes its opposite, negative 3. And you're not done. A lot of students leave it here. But the inverse matrix of a 2 by 2 is a 2 by 2 with nothing out here. So we're going to distribute, distribute. So I'm going to reduce this to 4/14, which is 2/7. So negative 2/7. This doesn't reduce, so it's negative 9/28. This is negative 3/28. Pretty weird looking answer. And then this is negative 1/4. And that would be our inverse matrix. All right. What's the determinant of C? Well, that's funny because we've already figured it out and we needed to. It's 28. Okay. Let's keep going. Okay, so this one's just straight and forward. Multiply F times G. Kind of done these before. So this times this, but we got letters, is 2A plus 1C. That's what goes in the upper left-hand corner. Then this times this is going to go in the upper right-hand corner. So that's 2B plus D. And then this guy is 5C. Whoopsie. My brain went haywire there. Don't know where it went. That's 5 times A is 5A. Negative 3 times C is negative 3C. It's bottom left. And the bottom right is going to be this times this. That's 5B minus 3D. And there's our answer. Now they're going to get a little tricky with us, a little lippy. It says find A, B, C, and D such that F times G, that's what we just found, equals, now here's the key. This right here is called that little I represents identity matrix, which is just 1, 0, 0, 1, which means this stuff has to equal that stuff. That stuff has to equal this stuff. This stuff has to equal that stuff. And this stuff equals this stuff. So that's kind of a crazy looking problem. But we're going to tackle it. So So we're going to start with the green. 2a plus c equals 1. Now notice this also has a and c. So we're going to bring the orange stuff with the green stuff because it just fits. We're going to create a system of equations, and we're going to be able to solve that for a and c. Now we're going to do the same thing here. The yellow stuff, 2b plus d equals that yellow thing, and then 5b minus 3d equals 1. We have two systems of equations to deal with. So on this one, I'm just going to multiply this by 3 because I can see to attack the c's. 6a plus 3c equals 3. I'm going to add these together. So I get 11a equals 3. Divide by 11 and I get 3/11. Kind of a weird answer. But I need to find c. So I'm going to pop it in here because it looks the easiest. So 5 times a, hope I did that right, minus 3c equals 0. This is 15/11 minus 3c equals 0. So negative 3c equals negative 15/11 because I'm bringing that over. Now I'm going to multiply by negative 1/3. Some of you are like, well, why didn't you divide by negative 3? Because I don't want to divide a fraction by a whole number. It just gets wonky looking. So I'm just going to multiply by the reciprocal. So I get c is 15/33. Now I'm going to do the same thing over here to find b and d. Hopefully they're not as crazy. I'm going to multiply this guy by 3, attacking the d's. So I get 6b plus 3d equals 0. Add these, they cancel. 11b equals 1. Divide by 11, I get 1/11. Then I'm going to plug that into here to find d. So 2 times 1/11 plus d equals 0. This is 2/11, so I'm going to subtract 2/11 from both sides. And so I get d equals negative 2/11. Kind of crazy. Anyways, my answers are all over the place, but I think you get it. All right, number 16 is just take matrices and make us kind of think our way through this. So it says, calculate x if 2x plus c equals d. Well, I know right away that I could just, I don't know what x is, obviously, because I'm trying to find it. I do know what this is, and I do know what this is. So what I'm going to do, and I just have to think out loud because I don't want to tear up all this space, but I'm going to rewrite this as 2x equals d minus c, because I'm trying to find x. So if I take d, 0, 3, 4, negative 3, minus c, which is 3, negative 2, negative 5, 1, and I just, well, subtract all this. 0 minus 3 is negative 3. 3 minus negative 2 is 5. 4 minus negative 5 is 9. Negative 3 minus 1 is negative 4. So I have this weird equation now. I know what this equals. It equals this. So I have 2x equals negative 3, 9, 5, negative 4. So I could divide both sides by 2 or multiply both sides by half. I'm going to multiply both sides by half and use what's called the scalar rule. You're just multiplying everything by half. So this would be negative 3 halves, or negative 1.5. This would be 9 halves, or 4.5. 5 halves, or 2.5, and that would just be negative 2. And that's what x has to equal. Strange problem. Now, you guys, kind of a really abstract question, so I'm going to try to make this simple for you. It says, suppose you want to multiply a 5 by 11 matrix. Remember, 5 is the number of rows. So I shouldn't have put a C there. That's why I was pausing. That's 5. And then 11 is the number of columns. And it says, for what value of C, so in other words, there's another matrix with different dimensions, but what do we got to know about C? In other words, how many rows? So 1, 2, 3, 4, 5. Nice job. I put 6. Sorry about that. Act like that didn't happen. In other words, if we multiply this by some other matrix, what do we have to know about how many rows there are in the other matrix? Now, to help you understand this, I've taken a legitimate 2 by 2 matrix, and then I'm going to just go like this just to talk out loud. What if I had a different matrix like this? Could I multiply this together? Well, this times this would give me something here, and this times this would give me something here. So I notice this has 2 rows, and this has 2 rows, and that would be a requirement. This would have to match this. So if this is 5, there would have to be 5 rows in the other matrix. They have to match. I guess I was doing a lot of that problem without you guys being able to see up here. But what I said was, like this one right here, there's 2 rows here, and there's 2 rows here. So even if I had more stuff here, 4, 6, 7, 8, this would still work. This times this would go here. This times this would go here now. This times this would go here. In other words, the point is you need 2 rows to match these 2 rows. So therefore, I said up here, if they're talking about a 5 by 11, then if this has 5 rows, the other one has to be 5, so C has to be 5. So we'll talk about the rest of the questions in a second. So sometimes as a math teacher, I just like to delete these videos and never show that I'm a human being, but I just had the epiphany. I tricked myself by picking a square matrix, and this is a 2 by 2. So something tricked me, and that is when I picked the 2 by 2 square matrix, it came out too easy that my answer is going to be 2. But I want you to look at this. There's 11 elements in this top row, and that first top row has to hit 11 elements in order for it to work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this one would multiply against that one, plus this one multiplied against that one, plus this one multiplied against that one, and so forth. So if I have 11 elements in my first row of my first matrix, I need 11 elements in my first column, which means I need C would be 11, not 5. So there we go. There's a math teacher just being honest. And the next question is also going to piggyback that. Given this value of C, well, it wasn't so given. I had to figure it out. What will the dimensions of the product matrix be? In other words, we know there's 11 rows, but now notice, then this, we've got 5 rows over here. So this would have to go through 1, and then understanding the concept of D is the number of columns. Notice, if we actually had this one right here, which is 11 by 1, it would work, because this would go through this, and that would be kind of like, you know, our answer right up here. And then we'd go this whole row times all of this, and that would go here, and then this through this would give us another one, and then we'd have a total of 5 things. So we could have 11 by 1, but if we had another row of numbers, so 11 by 2, I would simply do that. I would hit this by this, the first one, and that would go here. Then this would hit this one, and that answer would go up here. So really, this number can be any number, 1 or above, and then that would work. So I'm going to answer that. 11 by n would be my answer. All right. Let's get on to these. Solving systems of matrices. Well, you could use substitution. You could also use addition, but they say use matrices, which is shining a light on Kramer's rule. And remember, we got d, we have dx, and we got dy. Now where do we get d from? Take out the coefficients, as long as they're set up initially like this. So it's 4, 3, 7, 5. We know this is a 2 by 2. So that'd be 20 minus 21, which is negative 1. dx, the clue is we replace the x column, because remember this is my x and this is my y, with my constants, and somehow this works. 6, negative 5, 7, 5, figure out the determinant. 30 minus a negative 35 is 65. And then we do the same thing with my y. Is now my y column is replaced with my constants. So my x's stay the same. My y's get replaced with this. So 6, negative 5. Calculate it. Negative 20 minus 18 is negative 38. So, in order to use Kramer's rule, we have to remember that x equals dx over d, y equals dy over d. So we can figure that out quickly because of that negative 1 down there. dx is 65 over negative 1 is negative 65. dy is negative 38, but over d is negative 1, so that would be positive 38. X is negative 65, y is 38. Okay, let's try this one. This one's a little bit more challenging. I might get a piece of, well, I better save this. That's 16 minutes. So we'll see you in a little bit.